Actually, the time between 0 and 5 tau is called the transient phase, where the voltage UC is variable. At 5 tau, practically the capacitor is fully charged. So we say that the permanent phase or the steady state is attained between 5 tau and T/2. Actually, the voltage UG equals E is an asymptote for the function UC. So when the time here tends to the infinity, when t tends to the infinity, exponential minus t over tau or exponential minus infinity tends to 0. So UC that is equal to E1 minus E minus t over tau, as this one tends to 0, so UC tends to E. So here, as time tends to the infinity, UC tends to E. What about the tangent to the curve UC? This is the tangent at T0 equals 0. So starting from T0 equals 0. Actually, this tangent cuts the asymptote UT equals E with a point of abscissa T1 equals tau. In this part, we want to verify that T1 equals tau. So we know that the slope of the tangent at T0 equals 0 equals derivative of the function UC as function of time at which point or at which instant T0 equals 0. UC equals E minus T over tau. Derivative of UC as function of time equals derivative of E is 0. Derivative of this expression minus E is constant. Derivative of the exponential is minus 1 over tau E minus T over tau. So equals E over tau E minus T over tau. So here we replace this expression here equals E over tau E minus T over tau. Now, since the tangent to the curve you see is considered at T0 equals 0, so we replace the time instant by 0. So E over tau exponential 0. Exponential 0 is 1, so it's E over tau. Now, graphically, slope of the tangent at T0 equals 0 equals let's consider this triangle. This is the hypotenuse. This is the right angle triangle. Okay, so the tangent is forming an angle alpha or theta with a horizontal. Okay, so this side is the opposite to theta, and this side is the adjacent to theta. In this triangle, tangent theta equals opposite over adjacent. So the opposite to theta, this side, equals what? Equals E. And the adjacent to theta equals T1. So here we consider that we don't know that T1 equals tau. We want to verify that T1 equals tau. So this side equals T1. So the slope of the tangent at t equals 0 equals the slope of the tangent at t equals 0 found graphically. By comparison, E over tau equals E over T1. Then T1 equals tau. So yes, the tangent, this tangent to the curve you see at T0 equals 0 cuts the asymptote UG equals E with the point of abscissa T1 equals tau. Now, what about the current I? Let's find the expression of the current I as function of time during charge. Applying the law of addition of voltage, E equals Ri plus UC. So I equals E minus UC over R. Now, we use the expression of UC as function of time to find the expression of I as function of time. So we consider E minus UC is should be substituted by its expression E minus E minus T over tau over R. So equals E minus E plus E exponential minus T over tau over R. E minus E is 0, so E over R exponential minus T over tau. E over R is I max exponential minus T over tau. Or we can find the expression of I by using the variation of Q as function of time, or C duc as function of time. So equals C. We already verified that the derivative of UC as function of time is E over tau, E minus T over tau. Knowing that tau equals RC, C times E over RC exponential minus T over tau, simplifying C, so equals E over R, E minus T over tau, or I max, E minus T over tau. So now, I equals E over R, or I max, E minus T over tau. Let's consider three specific instances of time. So at T0 equals 0, I equals E over R exponential 0. Exponential 0 equals 1, so E over R. Replacing this point on the graph at T equals 0, the current equals E over R. After a time T equals tau, I equals E over R, E minus the time T should be substituted by tau over tau. So E over R exponential minus 1. Exponential minus 1 is 0.37 times E over R. So after a time tau, the current decreases till 0.37 E over R. Now, at T equals 5 tau, I equals E over R exponential. Now we substitute the time by 5 tau over tau. Tau and tau are simplified. So equals E over R exponential minus 5. Exponential minus 5 is approximately 0. So after 5 tau, the current is approximately 0. So now we draw the variation of I as function of time. Okay? So it is decreasing exponentially during time. So during charge, UC is increasing exponentially, Q is increasing exponentially as they are proportional. UR is decreasing exponentially, and as UR and I are proportional, or UR is the image of I is also decreasing exponentially.